So the integration by parts formula obviously didn't come from outer space. It came from rearranging the product rule formula. That's all. I'll show you. We know that the derivative of two things times together is equal to the first, well, one of them, doesn't matter which, times the derivative of the second one, plus the other one, times the derivative of that one. There's a v on the top there. Now, say we take this statement and we just integrate both sides with respect to x. So, we integrate this. Now obviously this is going to equal the integral of this, because they're the same. So if two things are the same, then the integral of one must equal the integral of the other. Now what have we got going on here on the left hand side? Let's think what happened. We've got uv, that's two functions times together, then it gets differentiated, then immediately it gets integrated. So what we're going to be left with on the left hand side? Just our uv back again. It's got differentiated then integrated, they're the opposites of each other, so uv comes back. Now on the right hand side we can write this as two different integrals, the integral of the first one plus the integral of the second one. Right, nearly there. Let's put this first term here on this side. uv minus integral v du by dx is equal to the integral of u dv by dx, and this is the traditional way of writing the integration by parts formula, but normally we put this on the left hand side and I don't bother with the dx, and I put this on the right hand side and don't bother with the dx, just because it's a bit lazy. In fact, I don't bother with either of the dx's because I'm extremely lazy. So I normally write integral u dv is equal to uv minus integral v du. I'm just going to show you a little example so you can track where everything goes to and hopefully see the connection between integration by parts and the product rule. So what happens if we differentiate 3x sine x? Well, we'll hold the 3x still, differentiate the cos x, plus hold the sine x still, and differentiate the 3x. Okay, what happens if we integrate all of this? Well, if we integrate the derivative of 3x sine x, we'll get 3x sine x. And then we'll get the integral of 3x cos x plus the integral of 3 sine x. Now, which of those would we rather integrate? Not that one, because it's got a product of two things. This one, we know how to integrate that one. That's easy. So say we were looking at this one, 3x cos x, then we could rewrite it as this minus this, and that would be a way for us to find out what the integral was. So 3x cos x dx is equal to 3x sine x minus the integral of 3 sine x dx. Let's see what everything is. Here's our u was 3x. There it is. There it is. Here it is as well. U there. Here is our v sine x. Here it is. V. Here it is. V. Oh, in there, that 3, that's the derivative of u, because u was 3x. And on this left-hand side, I've also got cos x, which is the derivative of v. So I've got u times the derivative of v is equal to uv minus the integral of v times the derivative of u. And it just comes from u times the derivative of v plus v, oops, that one's v, v times the derivative of u.